Hello, everyone.
Hello, everyone.
Okay, good morning. Can you hear me?
Can you hear me?
Hello, can you hear me? Mr. Rave, can you unmute yourself?
Very
Perfect. I can hear you.
I cannot hear you.
Good morning. Perfect.
Oh, sorry. Okay. Hello, can you hear me now? Mr. Rave, can you talk? I can't hear you. Mr. Robert, can you say something? Say hi.
yeah.
Oh, all right, all right.
Some feedback.
Okay, that's good. That's good. So, please, if you can hear me, can you just send a message in the chat that you can hear me? Type you can hear me in the chat. All right, all right, all right. All right. That's good. That's good. Okay, I welcome every one of us to another edition of International Space Technology Convention. This is the con kind of is on and sorry. Okay. So first and foremost, I give up praise to every one of us that are here and Almighty God for granting us the grace and granting me the grace to be able to convey this year edition of International Space Technology. And also, I want to extend my sincere gratitude to Dr. Srimati Kasan from Space Kit, India, for our support during the planning and preparation process. Our encouragement and assistance were invaluable in overcoming the hurdle we faced in the course of the planning of the program. And my special appreciation goes to our invited guest speakers in live of Mr. Rave Arilu, Mr. Roberts, Mr. Solomon Apake, and all, Dr. Ashwaya Dara, and all, and all. As you all know that this year theme for the convention is harnessing cutting-edge technology for sustainable innovation in space exploration. And I'm breaking the theme down here. This year's theme highlights the convergence of advanced technology and sustainability in pursuit of space exploration. In the 21st century, space exploration has moved beyond merely reaching new frontier. It now focuses on ensuring that our venture into space are sustainable, ethical, and beneficial for humanity as a whole. Why does this matter today? Why does it matter? First of all, the reason why it matters is that technological advancement shaping exploration. From artificial intelligence and robotics to advanced material and propulsion system, cutting-edge technology are revolutionizing how we explore and interact with space. These innovations make mission more efficient, cost-effective, and capable of addressing challenges that were once immutable. Sustainable as a crucial priority is another part of the reason why this team is being considered. The growing awareness of environmental responsibility extends beyond Earth. Sustainable practices are essential to minimize space debris, protect celestial body, and ensure long-term exploration efforts do not harm the ecosystem of our outer space. This approach aligns with the broader goal of preserving resources for future generations. Another main reason for this team is addressing challenges in space on Earth. Many technological breakthroughs in space exploration have application on Earth. For instance, advancement in satellite technology enhance global communication, environmental monitoring, and disaster management. By focusing on sustainable innovation, we ensure that these benefits are maximized while minimizing adverse impacts. This is a call to action to all of us here. The team serves as a call to action for researchers, engineers, policymakers, and innovators to align their efforts toward a future where space exploration is not only ambitious but also responsible. Through the discussion at the IST24, we aim to inspire actionable strategies that address critical issues such as the ethical use of technology in space, mitigating space debris, developing renewable energy solutions for space mission, fostering inclusive and accessibility in space-related venture. By focusing on harnessing cutting-edge technology for sustainable innovation, IST24 underscores the need for collective commitment to advancing space exploration in ways that are innovative, inclusive, and sustainable. Over the course of this convention, we engage in inspiring discussion, explore groundbreaking innovation, and share transformative knowledge aimed at shaping the future of space exploration. To our dedicated participants, thank you for taking the time to register and join us for this remarkable event. Your presence and enthusiasm are what make this convention a success. I look forward to your active engagement throughout. As we embark on this journey together, let us be reminded of the power of collaboration and the limitless potential of innovation. Together, we have the opportunity to not only advance space exploration, but to also inspire sustainable solutions for generations to come. Once again, welcome to International Space Technology Convention 2024. May this event be a source of knowledge, inspiration, and meaningful connection. Amen. So, let the convention officially begin. So, before we start today, okay, I'm calling. How to share my screen. Okay, the first person on our list today to talk is Rafael Arilo Gomez. Mr. Rafael Arilo, I don't want to spoil your list, sir.
I don't worry.
Okay, I'm coming.
Perfect. Thanks to first of all, thank you very much to give me the opportunity to share some words about the situation. When you contact with me talking about the item of the meeting was very, very interesting because technology, sustainability, innovation, and in the space exploration, they are a lot of things. They are very complex and they are more interesting about. I am the director of the Stardust Consulting. This is a consulting company in legal and management of space projects. And we have a wide experience to advising companies in a lot of all these questions operate in the real markets. For this reason, they are all the different points you put in the title, they are amazing. First one, we're talking about technology. There are a lot of new developments that we can see maybe all the days when we can see news and specialized system about all the new launchers, new space mission that, technology is during all the space activities is one of the most important things that we need to follow for determine that should be an advance about this. And what should be the key points now when we're talking about technology? Technology will be reusable, will be efficient, and will be, well, sometimes including we are now debating about if nuclear in space is necessary or not, what does the lines for make this. Is more important that when we're talking about to have a consensus about the points, because during the last years, the concept of sustainability is very present in all the items, not only with the space, also within a lot of questions, but also in space. What is sustainability in space? Sustainability, for me, is the capability to continue using the space in the future. Now we are developing a lot of activities in the space. We are a lot of satellites, we are a lot of space debris. We need to understand that in the near future, we are produce more satellites, but flies to the moon, but not only for satellites, also for crew, for manned flight to the moon. Probably in the next 10 years, we will have around 6 space stations in orbit, plus the future base in the surface of the moon with a lot of people traveling. It's necessary this kind of sustainability for to give opportunities to develop this project. When we're talking about sustainability, we are talking one of the main points is the space debris situations. During the last few years, we make more satellites and more space debris than on the rest of the human space activity in the space. It's very important, all the question that we made for to mitigate and for to avoid the possibility to have more space debris situation as the limit time for to remain in orbit and to proceed when at the orbit in the 5 years after the final use of the operative life of satellites is very important and very relevant. Also, we are talking about space traffic management, because with a lot of spacecraft satellites, we need to have a control. And the most important is that this control need to be worldwide. It's not only question of one country or ESA in Europe or similar association worldwide. It's necessary to have a global control of space traffic management for safety and for to promote this sustainability. What should be the role of the United Nations Office for Space? What should be the role for European or American law? It's very important to work in this line, because without sustainability in the sense that give us this opportunity to continue working in space is very, very important. Innovation is the 3K. When we're talking about innovation, is develop of the technology I was talking before. Innovation is all the things that the companies they are englobed in the new space paradigm is working on, is working faster, working better, working with efficiency. In the last week, we have news about the possibilities that the SLS system for to go to the moon in Artemis, well, they have very contradiction because it's not reusable, his efficiency is not so clear, and well, some companies, they are giving opportunities to make this better, cheaper, and faster. The innovation for a lot of companies worldwide is more relevant. And the role of the public administration is very, very important in this case. We need to work to help all the companies, they are developing new activities, new products, and make science for to do it. And all this is for space exploration. It's the final exploration. What is the space exploration now? It's not only the exploration of the LEO. It's not only exploration of the lunar surface. We are talking about the exploration and use of the space. During a lot of time, we can use the LEO, low orbit in the Earth for more satellites of communications, Earth observation, and well, it's a very, very important point. But now the next step is not only the exploration, is the use of the space beyond this communication, navigation, Earth observation. We are talking about concepts like in situ resource utilization with all the complex situation about if we can do it or not, this utilization of the space resources in the space. I am agree that all the countries and companies, they are this capability, and we are creating some regulations, starting with the national regulation in some countries, as the United States, Luxembourg, Emirates, Japan, and the most recent, Italy. They are in the national law. This is recognized to the use of natural resources in the space, but also all the countries, they are signature of the Artemis Agreement, and today they are 48, and probably before the end of the year, we have 50. They recognize this right. But by another side, the association of countries with the leadership of China and Russia, also they are agree with the use of natural resources in the space. It's very clear that this space exploration is addressed also for the use of the natural resources in the space. And not only, we are talking about the concept of ISAM, is in space assembling and manufacturing. We can work in the space station, we can develop pharmaceutical, chemical, we can create a structure for to make more spaceships and more satellites using the advantage of zero G in the space. We are a lot of interesting new ways in the space explorations. And for all these legal questions, they are basic. They are basic in the national level with rules, with the security for the people to make investment in the space industry is more relevant that they are rules. But also we need in the international level, we have a very clear support in legal question for to promote this new space exploration and use of the space. The role of COPUOS should be very interesting, but due to the geopolitical actual question is at this moment is very difficult to have agreements between the two principal teams in the world. But at the final, you can see that, for example, people, as I explained before, people, they are in the Artemis Accord, and people, they are in the International Lunar Research Station, the leadership with China and Russia. They are maybe the same things with international collaboration, go to the space, make rules. I believe all the people is thinking the same, but, and this is a risk for the sustainability of the space activity. We need to working together and make this. For this reason, I believe the items of this workshop is very interesting and very important to share all the information about the possibility to working, because there are a lot of new development, a lot of new technology, and the future of the space activities for humanity is very relevant in this case. Thank you.
Hello, sir. Thank you for your speech, sir. Are you done, sir? Are you done? Such wonderful presentation. Such wonderful presentation. It's nice having you here, sir.
Thank you.
It's nice having you here, sir. Is there anyone that have a question that I want to ask Mr. Ravi? He's a space lawyer, so you can ask him any question. We're able to answer it. Mr. Ravi, you want to say anything?
Yes, I will remain here some time and hearing the rest of the people involved. Thank you.
All right. Let me check. Okay. Okay, since there's no question. So, wow, that's great. So the next person that I'll be presenting now to us is Mr. Esteban Corridor. Mr. Esteban Corridor, can you hear me?
Hello.
Okay. Can you unmute yourself? Want to see your face, sir?
Sorry, are you talking to me, Marvelous?
Yes, okay. This is Marvelous talking.
Okay.
Okay.
Hello.
Yeah, you're welcome. So, okay, thank you.
Nice to meet you.
So before I proceed, can we appreciate Mr. Rafael for a wonderful presentation? You can drop a comment on the chat to appreciate him. Oh, okay.
Hello?
I think there is a question. Mr. Esteban, please later. You are the one coming in next. Or Mr. Rafael needs to answer some question.
No, I don't have questions. Thank you. Please let me know when you want me to start.
Okay. Mr. Rafael.
Yes, I have the other question by Solomon with the contribute of Africa. Well, Africa, they have some advantage. For example, to put places for launching. A few weeks ago, I was in a meeting organized by the FAI in the of the ESC of Milan, and a representative of Kenya explained that they are some interest that the foreign people invest, because obviously Kenya, they are a privileged position for the make a launcher in the geostationary and equatorial orbits, but they need more expertise, they need more investment, and I believe that Africa have more opportunities to develop a lot of satellites infrastructure for give service to all the population that need more control about the risk situation, control of agriculture, working about calamities, and to have more control about the global situation. I believe Africa is one of the continents and the countries involved making more next step in the future with this. They are people more prepared for doing this. It's true that probably the budget question is relevant, but they are opportunities to collaborate between countries. They are opportunities to start step by step with projects, and probably a situation like the Make a Spaceport or to develop a specific technical question in universities should be very relevant. Contacts and need more advice for go ahead because they have a lot of resources that we can apply to put Africa in the space. It's not only a question of China. All the countries need to participate. And probably when we remember the Outer Space Treaty or including the Moon Treaty about the essential question that the space use is for benefit of all mankind, it's question that the African countries go ahead to participate in space projects to have this right to participate.
All right, thank you, Mr. Rabe. I don't know, Mr. Solomon, I don't know if he answered your question. Okay. Thank you, Mr. Solomon. And Mr. Rabe, and Sajike also asked you a question in the comments in the chat section. He said, "Hi, thanks for your insight." Sorry, please. Okay. Oh, hi, thanks for your insights. I agree with the need for space debris and management from now. What challenge have you identified into framing regulation to preserve resources? Hello, sir.
Sorry, can you repeat about the space resources?
Okay. He said what challenges have you identified into framing regulation into preserve resources?
Yes, well, when we're talking about the space resources in the space, we need to be clear that the main space resources at this moment is water, because to establish moon bases, we need water obviously to drink, to have oxygen, to have fuel. Is more important than gold, platinum, or another things, because we need to for living. And this is the reason that all the space mission is focusing in the south pole of the moon, that they are the area that have two essential points. Is craters within the bottom, they are ice, and in the top of the crater, they are light to generate energy. This is one of the questions also I have referenciated starting, that probably the use of nuclear energy is relevant for the next steps in the space, because with the nuclear power, we have generation of energy as an alternative for solar range, and also nuclear power for energy and for traveling, for propulsion, give us the opportunity to move faster for the solar system, not only for the moon, for asteroids, for Mars. And with traveling faster, we can reduce radiation risk for the human people. And with this, we can explore the question of natural resources in a second level. One time we have water, second main resource in the moon should be regolith. With the regolith, we can create infrastructure, we can protect against the radiation. We can use them because to have a stable basis in the moon, we can use infrastructures that we can cover with regolith, or we can use the lava tunnel to protect people from the radiation. One time we have both water and regolith, we can start to search rare earths. Africa have a good experience in this kind of materials, because Africa is rich in some elements that can give the humanity the opportunity to more development. And probably this is one of the reasons that for mainly the China's they are operating with more African countries to working with these rare earths. The experience and the mining of rare earths in the moon of asteroids in the medium term should also be interesting. In the next month, there will be a very interesting legal experiment with the arriving of the ESpace next mission to the moon, and they develop a experiment is to catch some lunar regolith and to sail to NASA. A private company sail one material, regolith, to an space agency. Obviously, it's a little amount of material. Price is not essential, but the question is to have a precedent of a sale of products between a company of a country in the moon. Well, this is the first step in a long term because the use of natural resources should be clear to maintain bases, to starting with create infrastructure and to develop commerce. First one between the bases in the moon and only with a special material, the high value, we can talk in the maybe in the long term about possibility of commerce of trade with Earth, because the most complex question about the utilization of the space resources in the space is that we need more energy to create. I was learning with, for example, in Luxembourg Space Week about natural resources of the people of the Colorado School of Mines. We need more energy in the Earth, more energy to create natural resources. If we need to make the same in the space, the question of energy is very clear. This is one of the cases that we need to working with a lot of different technologies to advance in the actuation of the human in the space.
Thank you, Rafael. Sai here. You actually answered my question in from three different contexts, like from technology, like a propulsion perspective, and also from pure resources perspective. I appreciate that. I also have a follow-up question, like which intrigued me because I know that we all know that there are more abandoned satellites in the space in lower Earth orbits and the other orbits as well compared to the active ones. So I've also seen that there are different, there's a category for differentiating the size of space debris, right? So less than 1 centimeter, less than 10 centimeters, like that. But the smaller ones usually tend to have higher impact because of the smaller size and higher velocities. But my overall question is, when coming to space debris, are there any strict regulations that may be coming into action maybe very soon? Because you might have an overall perspective. And how can engineers contribute to that, especially like tackling the space debris? Like, I would appreciate that. Thank you.
Yes, not the case in the actual world because they give us the opportunity to use more the space. Space is bigger, but if we put thousands and thousands of satellites with not more coordination between different countries, the final should be clear. When some countries starting to put one satellite, two satellites, the first constellation, Iridium, they are, I believe, 27 or 30 satellites. But now we are talking about constellation of hundreds of thousands of satellites and more constellation of thousands. At the final, we are to level of problem. A lot of satellites that they need to coordinate in different shapes in sun, but also they are a lot of space debris result of the situation to have more space activities. For this reason, one of the possible solutions that we have is, first one, all the new satellites that go to the space of these thousand of the space satellites, they need to have propulsion for the orbit situation where they finalize the living time. With this, the orbit, they can clean the space directly. Second one, if there are more satellites in the space that they are not in the actual time, the possibility to deorbit, not natural deorbit, because obviously with the time at the final all the satellites fall down, but to have a control at the orbit, the second opportunity is one of the activities of the works in the space, in orbit service. They are satellites that catch two satellites and the orbit. The problem to regulate this second way is that the same utility for cleaning the space or orbit satellite to another question. For this reason, we need to have some rules for establish who have the role that clean the space, if the companies that they have liability and the state of this company, they are international liability in front of the possible collision, because at this moment, they are not more collisions. In fact, they are only problems with the anti-satellites testing, but in the future should be a real problem. And each time, more or less, International Space Station and sure the China's Tiangong Space Station need to move for avoid collision with satellites. You know, the Council Ryan, that if there are the possibility to have more space debris situation in the space, is a risk for all the satellites and for all the future space station. It's very important to working with the question of the space debris. And the space debris is very linked with the space traffic management. We need to order all these because there are a lot of space objects in the space that need to have some control. I read in the chat about the conflict of interest in the future regarding who regulates which part of the space exploration. In the United Nations, they are a COPUOS office, the legal office that they made in the past all the treaties about the space, and now they are make some regulation, guidelines, soft law, because due to the geopolitical situation in the to make a new treaty. Probably one of the solutions for this regulation is to make an update new treaty, but the question is very difficult working in the United Nations. For this reason, if you read the Artemis Accord, is more or less is to take some points of the different treaties and put new thing as space debris situations, safety areas in the moon, something like this, is to create a soft law, because Artemis Accords is a political not binding agreement between countries, is not a treaty, is not an international treaty, is not binding document, but they give ideas that follow the same. And they make more or less the same, and in the International Lunar Research Station for the China, Russia, and the rest of the countries, they are agree. It's more or less is the same, but they seems it's impossible to make one document with the resume of this. It's very curious, because the people that they have the power to do is the United Nations, but in the real world, they are two blocks that they are starting. At the final, we are in a situation that is again to arrive to the moon, to the state, new economy. In this context, the people to arrive first and stay fit, I am sure that they win rights for to go. Okay, we can talking about United Nations treaty, something like this. But if they are more or less following international rules, people to arrive first have more rights about us. This is, for example, one of the reasons that when the talking about the role of the African countries in the space activities, to be present in some of the initiative is very important, because at the final, the people that don't work in the space will be very late to arrive for, obviously, some advantage. It's very important to participate in the space activities at each level, but to participate.
All right, thank you, Mr. Robert. Thank you. There's another question on the comment that I myself I dropped. You go through it, sir. Another question in the comments in the chat section. The question says, as human exploration and potential settlements of Mars become increasingly feasible, what international regulation, law, or treaties are being established to ensure responsible and sustainable material development?
Yes, the question of Mars, I remember one comment a few years ago of Mr. Elon Musk that they say, okay, Elon is going to the Mars and Mars is so far and there are no rules applicable to Mars. This is a mistake. All the international rules that in the Earth we made, the Outer Space Treaty, Rescue Agreement, Liability Register, all is not only for the Earth, it's for all the places that the human can go. Also, at the first moment, for the acting in Mars, we can apply all the rules that the international treaties, they are now for the low Earth orbit of the moon. They are the same. Obviously, in a long, long future, due to the distance between the Earth of Mars, we can make talking about some special rules made for the people that remain in Mars, because I am sure that in the future, at the same way that the people that remain in the moon, they remain in the Mars. And what should be? Obviously, law we can prepare, but at the final, they are a question, they are very important about this, is the facts. If they are international missions collaboration for arrival on Mars, we can apply this. If they are only private missions that arrive to Mars, obviously this private mission of private companies, they are under the rules of the national, the state of this national company. At this moment, all the states, they are sharing the Outer Space Treaty. By the moment, we are clear what should be the rules. But the question is that by the moment, the rules, they are very essential, very limited. We need to have more rules about the use of natural resources, the trade in the space, the rights about intellectual and industrial property, the capability to share more information. Well, there are a lot of things to do in technical, in scientific, but also in political and legal question, because at the final, the facts, they are moving faster for go to the space. And as you know, all the legal questions that remain to talking about 1 year, 5 years, and for avoid the possibility to the people make his rules with independence to the community, we need to take shares about this.
Thank you, sir. Thank you, sir. Thank you. Thank you. All right. Thank you, sir. Really appreciate your presentation, sir. Okay. Thank you. It's nice having you here, sir.
You're welcome. Thank you.
So our next guest speaker that will be talking next is Esteban Corredor. Are you there? Mr. Esteban, are you there?
Hello, can you hear me well?
Yeah, you are next, sir.
I am good. How are you? And thank you for inviting me here. Marvelous. It's an honor being here.
You're welcome. You're welcome. You're welcome. So you can start your presentation, sir.
Well, I will talk I will speak mostly about my experience as hardware developer in Skyline and in the KSF Foundation, one non-profit foundation for aerospace educational CubeSats. So I would like to start with talking about the general system, how we designed these small CubeSats, just for present the two companies where I have worked. Skyline is one, well, currently it's not active. It was one company who manufactured CubeSats. It was based in San Francisco. We designed one complete system using the EPS as the base of the system. Let me share my screen to show you some of the job we did. Second, okay. I will share my screen. Yes. Can you see my screen?
Yes, we can. Yes, we can. Yes, we can.
Okay, so I will talk about with the system how was designed. Give me a second. Apply. This is the complete CubeSat. We have here the EPS. This is the.
Come from a form from
it has the all the powers on the electrical power system, and as you can see on the top, we use the standard PCI 104 port to connect more modules on the top this way. So if you can see, so this is small sockets on the middle of the EPS. This is done for saving for saving space. We used something called picoboas. They were very small, and they were plugged on it. Let me show you here. Can you see in the at the left of the picture? The PCB, the small PCB. So what we do basically, we have the base of the EPS and we plug the telemetry board on this very small PCB, but which is this one in this case. This has LoRa module for this version. This was one of the first versions we had for the telemetry board, but this socket is compatible with. It has all the pins. It has connected in parallel all the pins of the big connector. So the goal here was to save space, because I have one regular CubeSat. Let me assemble it for you. Here we have this is the normal, the regular one. Here we have the EPS. Later we have here the OBC. In this case, this is from KSF Foundation. This is one cheap version. This is based on EPS 32. Well, in this case, we take a lot of space for making the basic of the system. What we were doing with the Skyline was saving a lot of space. So we'll have about 70–80% of the volume available to put in here all the payload, which the one was offering more space for the clients use their own payload. Okay, let me show you more. We use it in this case. I would like to tell you about, we were working on one star tracker system. I guess, I'm not sure if Robert already talked, but Robert was making one algorithm to implement on one of these small picoboards. So one of these, the OBC specifically has a very good power processing. We were working on, we didn't finish it, but we were working on using this OBC to process the pictures we had, taking the pictures and using them as a star tracker to make one kind of stellar map to recognize where we will located. Besides of that, we worked also in the deployment system. I would like to show you. We found a way to make it more efficient. We use an Ignore to lock the panels. So when we use it, it's a hinges based on springs, which was very efficient about the cost. So we made this. Okay. Let me show you here on the, I think I have here one picture. Here you can see one animation of the, this is the EPS. Let me show you. And here we have the complete assembly of the CubeSat of Skyline. So the external the module on the top is the one thruster. Okay. Let me show you anything else. Well, here we were assembling this one. Here we have the 3D pictures, and here you have other pictures of the CubeSat already assembled. As you can see for the sides, if you can see it like a sandwich, and we had this panels where inside they have HDD to act like they're a spinner. So this was to create the strength to handle the flying control of the CubeSat. We have in that case we have several tools to handle the flight control of the CubeSat. We have magneto-torquers as in each axis of the CubeSat, C, Y, and X. We also have this HDD with wire spinning head to control the position of the CubeSat. And the last actuator was the thruster on the top. Okay, this was some about the harnessing. Jose will tell you about that. Jose Meneses, he was invited too. Well, here we have more models. We have here as you can see, we were using the deployment system for 4 antennas. It was created by Jose. Here we have one of the small modules, LoRa4. This was the telemetry picoboard. And here we have other video of the CubeSat. Yeah, well, we made a lot of versions for everything. We were working during 2 years. Well, that's about the Skyline. About KSF, I worked with KSF before Skyline as volunteer about 4 years ago, and he asked me to make one educational CubeSat. I make them one ESP32 based CubeSat. So let me check. I am still sharing my screen. Hello, Marvelous?
Oh, hello.
Okay.
Hello, can you
I stopped. I am still sharing my screen.
Yes,
Yes.
yes, yes, yes.
Okay, here. Oh. Okay, it's okay now. I stop it share. Okay, so I want to show you now. I was working with KSF Aerospace Foundation as volunteer. I made one small module based on ESP32, and they had one launching on Stratosat. So in this case, for the Stratosat, we measured some variables like radiation and that kind of stuff, temperature. From a couple of months ago, they wrote me again to update their version of their small sat. So here it is. I follow with them. They asked it to me. So I have the EPS with 6 solar panels, one for each face of the CubeSat. In this case, I made very small chunks. So in this case, I have two lines for charging to have a little of redundancy. Yes, so I used one integrated circuit which has included the MPPT, has the battery charger and everything in only one small integrated circuit. So I used two, one for each battery. In case of one of them got damaged, so three panels charge the battery 1, on the other 3 charge the battery 2. And if this module is very simple because it only has 3.3 volts, so it was one more easy job to do. As you saw on the previous presentation, the Skyline was very complex EPS. It has high current power rails. It has 3.3 volts, 5 volts, 12 volts. Each one very complete EPS. So this was a little more easy. And the other modules of this CubeSat are the OBC and data logger, which, as I told before, is based on ESP32. It has one real-time clock, one SD card to save the data, and it has one USB connector to, as this is done, focused on the educational CubeSats. This can be connected directly with Arduino to load the data. So this is almost plug and play. No, yeah, just this is plug and play. So the idea is the students can play with this. And the other module, okay, in Fortis we have 4: the EPS, the OBC, and we have the sensors module. So let me check for a second. Here we have for LoRa. 43 most used frequencies. 915, the European 868, 868, and the 433. I don't have it installed yet. It has here the GPS and the coin battery for the real-time clock, and here we have the sensor. So let me show you how this has one small code loaded. So let me show you. As you can see here on this small screen, the goal of this is the students can see how program it and play it while loading code. So I don't know if you have any question about this couple of projects.
All right, thank you. Thank you. Is there anybody that have any questions? This is a wonderful presentation. Thank you for a wonderful presentation. Thank you. This is a nice one. Is there anybody that have a question? Okay, someone have dropped a question, I guess. Yeah. In the chat section, he said that, hello, Esteban, thanks for sharing your work. Based on your work at Skyline with CubeSat, how feasible is it to integrate water vapor powered thruster into CubeSat mission? 6U or 12U or above? Could this approach support advancement in sustainable and efficient propulsion system for small satellites? You can also check the chat section.
I'm sorry, it's the question on the chat.
Okay. Check your chat section. You will see it here.
Okay. Oh, check last chat. Water vapor power clusters. Water power. Well, I am not sure about that. I remember we had about the thruster. Fishing propulsion. Well, there are some restrictions from the launcher company. I mean, I've been talking about this say question based on the thruster based on water vapor. It's interesting. I didn't see the water steam thruster, but we had some discussions when we were working with the thruster. We expected to use compressed gas. There were some restrictions. I'm sorry. There was some restriction with the launcher company. So we would have to be sure it can be done. We will have to check if we can put this kind of thruster on the CubeSat for the launch. Okay, everything is always about the restrictions of the launcher. Well, there is guys who is constantly working on the thruster technology. We met a guy. We bought him a couple of thruster when we were in Skyline. It's very interesting. I am not sure it exists. I don't know if will be very interesting to see that kind of thrusters. Okay, Solomon, how can someone get in touch with you regarding your projects? Well, I am on LinkedIn. You can search me as Esteban Corredor. So you can find me. Do you have any other question, Carlos?
All right.
Thank
all
you.
right.
Thank you, Esteban, for answering my question regarding that thrusters. I saw this. I fell into interest with CubeSats during the COVID, but later during my master's project, I just wanted to test the computational analysis of different fuels, especially in small satellites. So I took inert gases like argon, nitrogen, normal air, and then water vapor also. But then when I was doing my research, I also saw ESA, like European Space Agency, already did that maybe during COVID time. So they tested one small satellite like water vapor powered. But what intrigued me was when I did the end results of my master thesis, I found like when you compare to inert gases, water vapor was producing more thrust, but also the shock waves was not that much prominent to actually cut down the exit Mach number drastically. So it was very interesting to see, but also I don't know if it's too far, but then I related that to the lunar ice concept, right? How everybody's talking about you can use the lunar ice to get your hydrogen for your fuel, but then water vapor would be one of the constituents coming out of the products, right? Byproduct. But we maybe if we can still use that water vapor somewhere like just to propel, just to maneuver for small satellites, obviously more than 60 centimeters or 50 centimeters side. Yeah. So I just wanted to know your insight, but yeah, maybe it's interesting to think about. My only question was how feasible is it to think about for future actually? How feasible will the physics be? So yeah, it's interesting.
Yes, yes, it's very interesting indeed because um, I don't know also, maybe due to temperatures on this space, if you will work with water, maybe you need to one separated heater for one for the froze and another to evaporate and make this steam. No, I guess that's the way. I'm not sure. I never had heard about that before. But it's pretty nice because water is not explosive, so surely there is less restrictions about that for the launchers. Yeah, usually they are who put the limitations. Okay, anyone else has another comments or want to know more about the TC2 projects?
All right. Yeah, thank you, Mr. Esteban. I don't know if is there an avenue for those who want to learn how to design the CubeSat and electronics chassis. I don't know if there's an avenue for those who want to learn how to design. Is there an avenue? Like maybe you have a page whereby people can learn from you on how to come up with the same concept that you come up with.
Sorry, are you talking how we make the concept or for the design?
Okay, I asked that. Is there an avenue from your own end that people can learn from you as regarding how to build a model from scratch as the way you build your design now? No, you do 3D design, right? 3D modeling of chassis of electronic chassis for CubeSat or rockets. And I don't even understand what I'm trying to say.
You mean the integration with 3D models and the electronics? How we make the integration with the 3D models? With the electronics? I'm sorry, is that your question? Can you write it, please? Well, if it's about that, about the integration of mechanics and electronics, Well, we export the models. We use the 3D model for each component, and later we export it. And we use it, in this case, I worked with Jose Meneses. He will talk here. And what we did was export it to SolidWorks, and he made the integration, and he also can make the animations. In this case, we use Blender for the animations.
Sorry, I've not unmuted myself. How do you, and Mr. Esteban, are you still there?
Oh, you mean if I have availability for anyone who wants to talk with me? Yes, of course. Please, I will share my LinkedIn link. So yes, you can ask me. I am currently okay. Here you have my LinkedIn. So you can tell me anything you want.
All right. Okay,
Yes,
thank you. Okay, thank you. And sorry, one last question that I have for you. Thank you for
Yes.
such a wonderful presentation. And I want to ask that, how do you test your model design, the one you model on your computer? How do you test it? And what I mean by testing is that, how do you check if they will work in real life when you print them out with maybe your 3D printer or 3D device? Like, how do you test those models if, like, for them to work effectively before you printing it out?
Well, we made the most of testing here in the office, but before being launched, it has to go for one camera for testing the electromagnetic emissions. It has to pass some testing about electromagnetics, other about vibrations, to be sure it will not be collapsed during the flight, because during the flight it has hard strength when the rocket is being launched. So we test everything for separated each feature, so we can be sure everything will be working. In Skyline, we had one vacuum chamber to emulate the space conditions. It was in San Francisco. So yes, there are ways, and always the documentation in NASA is very helpful for everything. There is documentation for everything. So it's always about reading a lot and follow the standards. And it used to be enough to be ready. And also the launcher. The launcher company always has a good documentation, and the compliance need to be accomplished before the launching. So always is about reading a lot. Do you have any other doubt?
All right. Thank you. Is there anyone that have any question again? If you have, you can drop it in the chat. If you have any question, can you drop it in the chat, please? All right. I think there's no question again. Thank you for your presentation. It's such a wonderful presentation. Thank you, sir.
Thank you for inviting me, Marvelous. It's an honor being here with you.
Thank you. I really appreciate it. Okay. It's like we'll be finishing on time today. That's great. That's great. Okay. Who next to speak with all is Mr. Solomon Kwaki from Cyberspace Solution, Ghana. Hello, Mr. Solomon, are you still there? Hello, Mr. Solomon, are you still there? Hello, Mr. Solomon. All right. All right, and okay, can we quickly go on a recess for 15 minutes as we are expecting our next guest speaker? So let's go on recess for 15 minutes. Thank you.
called Xavier Space Solutions. Obviously, it's a huge privilege to be given the opportunity to talk to you about this wonderful theme on this year's conference. I think I did listen earlier on the talks from our earlier guests, and I do really find it intriguing. And I think in my presentation, coming from somebody who is actually doing stuff in space science or space technology in general, I think it will be an interesting conversation to add up to what we have already had today. So I would start by talking a little bit about myself and what we do. So I'm an early career space scientist. What that means is I do, well, I'm involved in designing small satellites, and I do also do a little stuff also in astronomy. So I did a master's in astronomy, to be specific, studying young massive stars at the University of Leeds. And in my free time, I do these satellite stuff. But of course, I should say that I do have a degree in physics, which makes it a bit easier if you want to design satellite and spacecraft related stuff. So in today's presentation, I'll talk about Xavier Space Solutions, what we do. I'll talk a little bit about some of the miniature satellite we are working on, and sort of weave the conversation into the theme, which is talking about space technology and how we can develop it, of course, in a sustainable way. I'll also touch on the future of space in Africa a little bit, and finish the entire talk talking more about space technology for sustainable innovation. So at Xavier Space Solutions, our mission is to design and build affordable satellites, which, so on your right-hand side, the image that shows one of the small satellites we are developing, which I'll talk a little bit more in detail. So our mission, which I'm sure most people from Africa would relate with, and even from other developing countries would be, in the end, take part in launching these miniature satellites, which will be able to help in connecting the African continent in terms of being able to provide internet, which the likes of Elon Musk, among others, are being able to achieve at the moment. So moving on, so I will just give a background on what miniature satellites are and what they are doing in the field at the moment. So if you know a little bit about technology in general and how far we have gone from the 1990s to current, you'll notice that we have moved from developing very, very huge satellites to actually now developing very small versions. And I will show you which different sizes and weight we have. But the ability to be able to make these technologies very, very small have really meant that we can actually do a lot of stuff these days. So you can think of being able to observe the Earth, being able to send data from Earth to space and then the other way around. We have been able to do this a bit faster because of the fact that we have been able to miniaturize most of these space systems. And this is very, very great. Again, I would refer to the conversation the first speaker had about how we can actually be able to mitigate having a lot of satellite, which I think I would again talk about in a bit, how from somebody who is a scientist and actually working in the field, how from our perspective we could be able to contribute to that, even though we still want to put more satellite into space. Moving on. So in terms of if you want to classify small satellite by mass, this is a chart from the EOS Data Analytics, and it shows the different types. So the satellite we are building is between the mass of 1 to 10 kg. So that will form or that will go under what we call the nano satellite. And I think we do also have a few stuff also around the Pico satellite range, which is just about 50. Well, the dimension of the satellite is that of a Rubik's Cube, if you know what that is. And it's just 50 by 50 by 50 mm in size. And these small satellites usually would be working in or are in the orbit of the low Earth orbit, or what some people can also call the near Earth orbit. And we believe strongly that these satellites is what the future is, and I will try to convince you why we believe so. So in terms of what we do as Xavier Space Solutions, these satellites that we design, we usually use off-the-shelf component, which means that it's cheaper to develop these satellites, and it's also lighter compared to conventional satellites. And this is very, very important because in the end, it means you need less money to be able to launch these satellites, because the heavier your satellite, the more money in terms of, the more money you spend in launching these satellites into space. And in terms of the research and development, the cost also increases depending on the different sizes. And this is the edge we have in terms of being able to do this. And I think it's important to highlight. So I will talk about some of the projects we have done. At the moment, we are working on a 3U. So apart from developing what we call the pocket cubes or the Pico satellites, we also do work in designing CubeSats. And one of our latest project is developing a 3U CubeSat platform, which will have an optical payload, which is basically for Earth observation. And the target is to do this in Africa, and these have different aspect to it, or different significance if you think about it. So some of the issues we have in Africa, and I'll use Ghana as an example, is illegal mining activities and also deforestation. Now with a 3U CubeSat with an optical payload, like I'm saying, would be able to contribute to this, because we will be able to look at these various problems or issues, be able to monitor and be able to sort of find major solutions to these things. So this is one of the projects we're working on. Another project that we are actively working on with collaborations from our partners in Serbia is what we call the Orbital Debris Management and Risk Mitigation. We do have a website for this, which I'll put in the chat in a bit. But the idea is being able to, the first thing is track satellites that are no longer working in space, and what some of the things we can be able to do to prevent it from being a problem, like our first speaker talked about. And in terms of what we do at X-Space, we are in terms of the orbital debris management, with some of the satellites we are developing, we have an innovative way of being able to track these satellites, even if they are not working. And I would like to talk about it in a bit. So moving on from the debris management, another project that we have worked on is what we call CANSAT Ghana, which the image on your right-hand side clearly shows what that is. So the idea is we teach students from between 15 to 18 years how to develop experimental satellites. And this is something we have run for, let's say 2 years. And we have reached about 400 students in Ghana, where we taught them how to build these experimental satellites. And they get to launch this using, let me see. Can you still hear me?
Yes, you can.
Okay, great. I did have a pop-up that was saying that I was muted. That's how I wanted to be sure. So we did teach these students how to build these experimental satellites, and they launched these various satellites using a balloon. Depending on what mission they choose, they do stuff from between taking weather data of their surroundings and being able to see if there's been changes the previous year. These experimental satellite they build has different different sort of things you can use it for. So apart from having to actually launch these satellite this experimental satellite into high altitude, you could actually use these satellites also as a ground station, which means they can use it, for example, as a weather station and to do some other different stuff. The experimental satellite they built also has a communication module on its own. So in terms of what we call the Internet of Things or IoT, these students could actually use these core modules for those different tasks. So moving on, I will now look at just briefly talk about the future of space in Africa. I'm going to do this using this chart from Space in Africa. So this is an institution which tries to provide data on some of the things that we do in Africa. What are some of the valuation in terms of how it's developing? And this is something from 2021, but I think the latest figures goes way beyond $19.49 billion in terms of how much it's valued. And you could see how much is actually put into the different aspects. So we have from satellite manufacturing itself in terms of infrastructure development and devices, and what we also call the sort of satellite systems, and then also components, which will also cover the propulsion systems, among others. I think in Africa at the moment, most of the sort of what we get or the end product of having to participate in space technology in general is all on the GNSS and similar services area. So that would be sort of using satellite data to understand our environment, or in terms of even remote sensing. And this is what the bulk of the African space industry at the moment is about. One aspect which is not gone into a lot is the satellite manufacturing, which is what X-Space is currently trying to contribute to. And there are a lot of things we can talk about in terms of what the future of African's space industry looks like. And it's something I'm particularly very fascinated about, because I think it's obvious that we have not had a lot of contribution in this. However, it still means that there's a lot of things we can actually do, because we do have the capacity, and because it's not so much developed, there's always different ways of being able to contribute to this. So to maybe hone in a little bit more into some of the things that the Africa in a whole are also contributing to is looking at the African Space Agency. So an institution which was established to be able to sort of promote the space activities across the continent. And I'm just putting this here because it's very important to know that the African Space Agency did come up with a strategy and a policy which sort of helps to be able to let each African country know what we are doing, or to be able to sort of direct the different things that different countries are doing into one specific sort of spot, which I think in the end helps us to be able to develop. So all the different aspects and things like what we are doing now, for example, talking about space and why it's important, these are all activities that I think in the long run help in developing Africa. So to summarize my own opinion on what the African space sector looks like, it's obvious that it's a highly potential field that will keep growing, and I think it's something we should be proud of. So moving on, I would want to talk about some of our short-term goals. So the reason why we are developing these miniature satellites or these small satellites is because our primary target is for African countries. So in different conversations, I think we have about only a few countries in Africa who have launched their first satellites. And there are several reasons why this is so. And one of the reasons is cost, right? And what we are doing at X-Space is, or Xavier Space Solution, is that these satellites we build are affordable, which means that African countries can sort of tap into these miniature satellites to start that or to break that barrier of being able to launch their first satellite with limited research and development. And this is these are the goals that we want to be able to reach in the next few years. So sort of finishing off my presentation and sort of touching on what the theme of this convention or this conference is. I mean, there are things I think the first speaker already mentioned, I think, Robert, in terms of what we can do to make sure that the space technologies that we build are not just going to, in the end, backfire or harm the planet in general. And one of those things we can do is to make these satellites as small as possible. What that means is, I mean, we will spend less money being able to land these satellites in space to do the same thing or the same things bigger satellites will be able to do. What that means is we can have enough, I mean, we can have money to look at some of the issues that the Earth faces, and also even direct some of those funding into space debris mitigation, like I've talked about. And I think this is very, very important. And this is something Xavier Space Solution we do have in mind, which is why we are developing these small satellites. Moving on into space debris mitigation. So we have our own space debris research lab. And what we do is we track inactive satellites. So we have, so we do have a lab in Serbia where we do track these various satellites. And I think we have published a few research papers on some of these satellites in space. And I think that is the first step, because when a satellite is inactive, right, sometimes the orbit degrades. And when that happens, it means the satellite launcher or the person who owns the satellite don't really know where the satellite is. And if we don't know where the satellite is, how can we be able to remove it, or how can we be able to sort of plan how to remove them in space, I mean from space if we need to. And that's one key thing that Xavier Space Solutions, we are involved in doing so. And I know there are other different companies who are looking into how to actually go and remove these. Now, from a scientist point of view, I should say that even the satellites that sort of, the satellite that do not have any propulsion systems, what happens is these satellites, their orbits degrade, right? And most of the time, these satellites will fall back onto the Earth. And what happens is, because they are very, very small, they burn when they enter the Earth's atmosphere, which sort of is another sort of natural way of being able to remove this. And this is why the likes of Elon Musk is launching thousands of these satellites into space, because in terms of being able to remove them from having to have different effects, there is a way. I should say that it could be better in different ways, but of course, I think we have had, or the earlier speaker had this conversation of some of the mitigation, some of the laws or the legislations we need to have to make sure that there's control, so that we don't just launch satellite into space because we can, but there's actually a thought process in being able to do that. I'll finish off talking about the call for international collaboration. So, for example, this conference that we're having is actually a good way to actually be able to look at how we can promote sustainability, because I have learned a lot from the previous speakers on some of the things we need to do to be able to ensure that we do not just pollute space with satellite, to be specific, but to be able to actually do this in a reasonable way and in the end not affecting us. Another thing I want to touch on before I move to the next few slides is so with the we talk about how we are actually going to or how we are contributing to space debris mitigation. So with the satellite that we are designing, there's this idea of putting what we call reflectors on the bottom of these satellites. And what we would have, or what would happen is, if say we land this satellite into orbit and something happens and you can't say power the satellite on, in essence it becomes a space debris and there's nothing you can do about it. But these reflectors that we put on the bottom of these satellites, they don't require power to turn on or to do anything. And with ground stations on the Earth, right, you can bounce lasers off these satellites, right? And that is a way of being able to track these satellites even though they are inactive. And I think that goes a long way into being able to design programs to be able to remove these satellites in orbit when we need to, which is something Xavier Space Solutions, like I said, we are working on. There is a research paper that we will be publishing on how you can actually do this if it's something you want to do. And obviously we would have this on the satellite that we are developing. So thank you so much for listening. And in Ghana, we say Medasi, which just means thank you. If you want to read more about the satellite that we are developing, you can do that by visiting zavsat.space, and that's on the bottom of your screen. Please feel free to reach out if you are interested in investing in what we are doing, because we are still in sort of the startup phase, and some of these technologies we are developing do definitely need help in terms of being able to scale up and reach out to more people who are interested in small satellites. If you're also looking to starting your career, you can also reach out to us. We do have a few roles that we will be advertising in next year. So we have several roles, so you can also check that. And of course, if you want to collaborate with us in terms of what we are doing in Ghana, feel free to do so. These are our address at the moment. If you would like to send me an email, the email is apekesolomon@gmail.com. If you want to ring us in Ghana, that's the telephone number. And like I've already said, the website is zavsat.space. Thank you so much for listening. If you have any questions, you feel free to ask.
Such a wonderful presentation. Thank you, Mr. Solomon.
Thank you too.
If you have any question, can you drop it? Before anybody asks question, I have my own question to ask you, sir. So as regarding your research in Serbia, if I made mistake, the tracking of satellites, hope is not costly to carry out that research.
Okay. Marvelous. Thank you so much for that question. So in terms of the cost, I think it's very simple, really, because the first thing I think we did was, so we have some cameras. So we had some old Canon cameras, right? So just like how you could, without even a camera, be able to look at the ISS, right, or the International Space Station from the Earth, depending on where you are and if it's not cloudy. What we started doing was using these old cameras, setting them up, and if you go to the NASA website, some other different websites, there's a way you can actually track the International Space Station and also some other satellites. So what we did is, so we set up these different cameras, obviously during the night. And what we can actually do is, so we have data on where we should see these satellites, and we set these cameras to be able to track them or to take pictures. And you need to do a few sort of designing some form of ground station to do that. But me having to talk about using old Canon cameras tells you, or sort of answering the question is to say that we started off with just a few dollars, really. You don't need huge investment to be able to track these space debris, really. Some old Canon cameras should be fine, and we have published a paper on what kind of cameras that we used. So I'll put the link to one of those research papers in the chat so that people who are interested in looking at the cost that will go into being able to track this, to take part in space debris mitigation in terms of tracking, you can do that. But yeah, it doesn't cost a lot as you think.
All right. Sorry, I still have one question for you. And how efficiency will it be for those used camera that you're making for tracking the satellites?
Yeah, so I mean, in terms of efficiency, it depends on what you want to do, right? To answer the question in terms of what we wanted to do, so the first thing we wanted to do was, people have launched satellites in space, and when the satellite is no longer working, they don't know where that satellite is. So for us, what the main thing we wanted to do is to find a satellite, or to see where these satellites are, right? We even, not just the satellite, but we also moved into like rocket paths. So when people launch satellite into space, where do those rockets go, right? And do they just float in space? When they do come back to the Earth or enter the Earth's atmosphere, which portions of the Earth, or where do they really go? So our main goal was to just track these objects, right? So in terms of efficiency for us, using these kind of cameras was perfect. We just wanted to track them and see where it is. We have a few sightings of I think Elon Musk's rockets. After lunch, we have tracked a few of them just to see where they are. So in terms of efficiency using those cameras, I think it depends on your what you want to do by like tracking these space debris or being able to pick them up. And for us, using those cameras was pretty efficient because we just wanted to see where they are and take pictures of them and compare to where we actually know they should be.
All right. Thank you. Another someone dropped a question in the chat.
Okay.
Mr. David. He asked that, have you ever carried out any debris operation?
Yeah, so I mean, it depends on what you mean by space debris operation. So if you mean sending something or sending, let's say, an instrument into space to actually, say, remove space debris, no. What we have been doing so far is just tracking these space debris to know where they are, because that's one of the huge questions in satellite development now. People don't know where the satellite is, especially after the orbit degrades, because you usually don't have information on it and you don't have a dedicated camera or, say, system looking at the satellite after it's non-operational. So yeah, hopefully that's satellite deorbiting, you mean? Yeah. So yeah, we haven't done any satellite deorbiting. What we do is to track these space debris to know where they are so that we can form. So I think the idea we have, or we want to in the end do, is with the data and where these satellites are and what we track, we can use them to form some form of model which gives us an idea of where all the satellites that are not operational are. Because I think there is, at the moment, I think there is a software. I think there's a website which I'll find, which shows you where all the satellites that have all been launched and are operational are in space. But there is not something like that for satellite that have, are inactive anymore. And what we want to do is with the data we collect from observing these various satellites, we can actually use that to form a map of where all the satellites that are non-operational are. And I think this goes a long way into helping when we actually find a way of actually being able to deorbit or remove them from space.
All right. Thank you. Is there anybody that have any question again? Sorry, how about the progress of your WCRC for Ghana section? Are you still doing it?
Yes, so WCRC, or the World CANSAT Rocketry Championship. So it's a yearly program, and I think every year what we do is we send representatives from Ghana to the event. I think this year's happened in Portugal. I'm not too sure, but yeah, so we do take part in that, and we are still collaborators with the founders of WCRC, or the World CANSAT Rocketry Championship.
All right. Thank you, sir. Thank you. So it's nice having you here. Thank you for your presentation.
You're welcome. Thank you.
So I think since there's no question, I think.
There's a question.
Sorry, who's that? I want to read the paper about it. Okay. Mr. Solomon, I think the question is to you.
Yeah, actually, you can't wait to read the paper using the yes. So it's called the Retro Reflectors, and I can send you the abstract if you send me a message on LinkedIn. We are hoping we can actually submit this at the International Astronautical Congress next year in Sydney. So yeah, you would just have to wait a little bit, but I can send you the abstract to read. Yeah. And I'll also, I think people are still here, so I'll just send you the links to the space debris related papers that we have written so far. So just give me a minute and I'll find it.
All right, no problem. Thank you for your presentation. So next person that I'll be talking with us is Mr. Roberts. Are you still there, Mr. Roberts?
Yes, Mr. Allende, I'm here. Okay.
Yeah. You are next, sir.
Can I start my presentation? Or wait?
All right, as we're waiting for Mr. Robert and Mr. Solomon, are you still there?
Yes, I'm here. Yeah.
Someone drop a question in the chat section. Yes,
Yes. So in terms of the effect of this space debris, so I think the number one issue really is the fact that if we have a lot of these space debris, so i.e. Satellite one, which are not operational anymore, what's going to happen is you would have a lot of basically metal, because they are made up of metal, surrounding the Earth, really on the in near Earth orbit, right? And what this had different effects. One of those effects is, I mean, if these satellites are large enough, what actually happens is when they are no longer operational and their orbits degrade. So if I mean the orbits degrade, so if let's say you put them in high Earth orbit, right? They would maybe come into near Earth orbit, and what that means is they would end up having to enter the Earth's atmosphere. So if it's heavy enough, so you can just imagine big satellites heavy enough, it wouldn't bend completely, and you would have basically metal falling onto the Earth. That is a very wild scenario to think about. But I think there's even I think last year something like that happened where one satellite that was deorbit, right? Some time ago, and the orbit degraded, actually entered the Earth's atmosphere and didn't bend completely and fell somewhere on the surface of the Earth, right? So one of the sort of what people are scared about is if we keep launching these, especially the big satellite, and these things happen, it means we would have metal falling on back onto the Earth, which obviously, I mean, it could damage buildings. It could, I mean, people could lose their life from having these things fall. But in terms of what it could actually do for the Earth itself, we know that space, obviously, I mean, has effect on the Earth in terms of temperature, magnetic field, among others. So if you put more of these things there and you don't remove them, who knows? I'm not an expert in terms of magnetic fields of the Earth and stuff like that, but in general, it would have an effect on the Earth. So I think that's what most people are worried about.
all right, thank you. Thank you for the answering the question. Thank you, Mr. Solomon. So I think, are you satisfied with the answer, Mr. Paul? Just drop yes in the chat section if you are satisfied with the answer. All right, thank you. Thank you, Mr. Solomon. So, Mr. Robert, are you still there? All right. Are you ready, sir?
Yes. Yes, sir. Yes, sir.
The floor is yours.
Please let me to share my screen.
All right, sir.
Can you see my screen?
Yes, we can, sir.
Yes. Okay. Well, AI in space technology. Let's go. Okay, people. I'm an electronic engineer, an AI engineer also, and thank you, Mr. Allende, for inviting me to this convention. It's really an honor to be alongside these people, these smart people. Okay, the purpose of the presentation to explore the role of artificial intelligence in space technology. The relevance is becoming to enhancing mission efficiency, safety, and data analysis. The current landscaping of AI in space, autonomous navigation for spacecraft and rovers, data analysis for satellite and environmental monitoring, predictive modeling for mission planning and resource allocation. Okay, the key players, NASA, European Space Agency, the private sector, companies like, SpaceX, Marvex, Cortex, and another. Case studies, people, NASA, use of AI, implementation of autonomous decision-making and deep space mission, such as the Hera planetary defense mission. In the last October, I think October 15, October 20, NASA and European Space Agency launched the Hera mission as an ops sub-project using deep learning algorithm to enhance image quality and determine factors of her surface. Edge AI innovation at Cortex, development of AI accelerator for real-time processing in space mission, focusing on energy, efficiency, and performance. Robert app, my apps. Implementation of AI to an star tracker for sat positioning and spaceships navigation, computer vision and prediction of landing site, machine learning, deep learning, LLMs to make BCI interaction with astronauts. Hera defense mission. Okay, October 7 is 7/2024 represents the mission to be impacted in Dimorphos and Didymos in deep space mission with two nanosats, okay? And is equipped with advanced autonomous navigation technology that allow to navigate through space and around asteroid without direct human controls. This capability is akin self-driving cars with a spacecraft which utilize AI to analyze data from various sensors to build a model of its environment to make real-time decisions. This is the main topic. This approach not only enhance the efficiency of the mission, but also ensure that Hera can adapt enforcing simultaneous and deep space environment, which is characterized by low gravity and complex dynamics. AI-driven data collection. The mission will be deployed to CubeSats, like the same CubeSat that show Esteban, that would assist in gathering details data about Dimorphos. These small satellites are designed to maneuver close to the asteroid and perform various scientific tasks. Okay, collect with the crucial understanding how the DAR impact alter Dimorphos structure and mineralogy, thereby refining future planetary defense strategies. Importance of AI, in the planetary defense. The integration of AI in the Hera operation underscore potential role in planetary defense system. This mission findings called lay the groundwork for future efforts aimed to protecting Earth from asteroid threats, turning what was one science fiction into practical reality. Robert and partner devs. Nano 1U, 1.5U, 4U, all U AI sat navigation. Like the another one question concerning the vapor, water vapor power maneuver or something like that. Okay. Another work, a computer vision candidate landing region for NASA Artemis 3 mission. This is a computer vision model, like a convolutional neural network to see the landing regions, okay, in the moon. Another work important to me is brain-computer interface, BCI for astronaut. The astronaut have a device in the skull, in the head, that can acquisition the signal, process the signal into feature extraction, translation, and commands, and this is the BCI application in the space for astronauts. It can control the ship with the mind. Is something related to sci-fi, okay, but it's real. Another work, sentiment analysis in astronaut by brain-computer interface. This is a model, AI model in machine learning that can receive the signal from the brain of the astronaut in shown in these numbers, okay, in this data set, and I can to process the signal like that graph of positive column, positive sentiments, negative sentiments, and neutral sentiments. Okay, these signals can show the state of the astronaut, the person on space, and we can predict the comportment in the environment in the space. Sentiment analysis by astronaut by the same computer interface. Here we can see the confusion metrics that show the neutral, positive, and negative sentiment. Okay. Another we can see the score of the model. The model has an 65% of accuracy, not too bad, but we can improve the model, and we need to reach more than 95% of accuracy for deployed in real life. Key benefit of AI and space technology: enhanced efficiency, autonomous operation, safety improvements. It can predict potential hazard, okay, reduce the need for constant human oversight, allowing spacecraft to operate independently in challenging environments. AI system can process vast amount of data quickly, improving decision-making process during missions. Challenges and consideration: technical limitation, for example, power of the computer power, dependence of robust algorithms, hardware in extreme condition, ethical and legal frameworks, okay, the need of regulation of the AI, including liability issues and international cooperation, the data security, protecting sensitive information for cyber threats, increasingly autonomous systems, the future prospects, the integration with other technologies, the quantum computing for advanced data processing capabilities, robotics for construction and maintenance tasks and facility and bodies, international cooperation. Africa, it's time for Africa. The role of global partnership, advancing AI technology for shared space exploration goals. The conclusion, recap of key points, summarize how AI is reshaping call to action, encourage collaboration among international space agency, private company, and researchers to harness the full potential of AI in future mission. People, it's time for Africa. Thank you so much. I have the video of the Star Tracker, the AI Star Tracker. Let me to finish this presentation to show the short video. Okay, here's the Star Tracker at 500 kilometers over the surface of Earth, and we can see how the model track the celestial body, and we can navigate with this information from the model. It's a single model. We can do more complex model, more computer power, more all. Okay. Thank you.
Thank you for the presentation, sir. Really appreciate it.
Let me do here. Okay. Any question?
If you have any question, please can you drop it in the chat section.
Mr. Solomon. Good presentation, Mr. Solomon.
Okay. I have a question. I have a question for you, sir.
Any
Hello, Mr.
question?
I have a question.
You have a question?
Yeah.
Okay.
Okay. Oh, my question is that how can we solve the issue of AI taking over the world in terms of engineering, in terms of space, in terms of rocketry, in terms of colonization of other planets? How can we solve such issue? Because as time goes on, when AI is being trained, they will take over. So how can we solve it? Because the time is coming that AI is more intelligent than us, because we are the one that train them to be more intelligent than us. And when the time comes later in the future, if care is not taken, how can we overcome such situation in case if the later over?
Okay, Mr. Allende, you are afraid about the AI?
Sorry.
No
Sorry.
problem, Mr. Allende. The AI can be more smart, can be more fast, can be more efficiency, can be more. But the AI is built by us. by the human. The human can do the barrier to the AI in space, in the earth, in all sides of the universe. The AI is a tool. It's not a person, it's a tool. To be a person, we need other things. And the AI is only a tool. It's a mathematical, a computing, an algorithm, a very complex algorithm, but it's a tool. It's a necessary tool. No, it's not a menace. It's not a menace. It's only a tool.
All right. Thank you. And in institution, okay, for example, if you look at the recent, I don't know if you watch when Nomos launch is this new Tesla model and the robots. I don't know if you watch it when you launch it. I think that should be last one, if I'm not mistaken. So, he created a robot in a human form, though it's made up of metal, not like made up of flesh, you understand? But can we say, how can we, because in a situation whereby we are getting to now, the time is coming that robots will be used instead of human, like it will replace human. How can we solve this challenge? Because that will lead to a lot of unemployed, and in a place where there's large unemployed, there will be a lot of criminal. You understand? Because people who don't have much money, they will want to look for a way to sustain themselves. So how can we solve such issue? How can we solve such situation if it arises later in the future when a robot and AI take over human?
Well, the robot of Tesla. Tesla showed the last month, I think, a show of robots, a controller robots, not really a robot controlled by AI. Okay, and I'm not a religious person. Okay, I'm engineer, and I can say that the robot need a soul. You can't construct a soul. You can do and put a soul into a robot. I don't know if you understand what I say, but I'm not a religious person. Okay, sorry, I'm an engineer, but the robot is a tool. The AI is a tool. We need this tool to advance in the science, in the technology. Okay, in all aspects. Okay, in all aspects, in security, space, in medicine, in all branch. Okay, we need the AI.
All right. Thank you, sir.
How do you question? How do you get the large data set to train the AI model to get adequate result from the model is a problem. Okay, really a problem. In space sector, we haven't we have a real problem to find a large data sets. Okay, to the Star Tracker, I had to review many videos because NASA and ESA don't share the information. Okay, don't share the information. It's not easy. I have a question. CERN, space.
Yeah, I have a question, sir.
Mm-hmm.
Okay, now, my question is actually looking at the issue of artificial intelligence and robotics. Can we
Okay.
envisage a point where artificial intelligence takes over as astronauts, in the sense that instead of now having crewed missions, we have missions simply powered by robots? Can we envisage such periods happening in the emerging trend of space exploration?
Okay, you say that we can send mission without human.
Yeah.
Yes. Yes.
Okay.
In this time we can send mission to all planets, all celestial bodies without humans, because the AI in this point is a tool, an advanced tool that can do it. Okay, that can do it perfectly. Okay, with the accuracy, the high accuracy of 98%, and very light lows. Okay, in terms of the metrics of the data set, the metric of the model. Okay.
All right. Thank you, sir.
Well detailed. I mentioned the brain computer interface mode. Okay, in another in another convention, okay, because the brain computer interface is very complex and is other thing, okay, other thing. The application is very okay. US UAV. You can put a BCI in many things. Okay, many ships, UAV, drones, rocketry. And you can do anything with that. Engineer David, collect.
All right, thank you, sir. Thank you. Is it that you have a video you want to play for us? I thought you had something you want to share. Okay, or are you doing?
Yes. You can. Freeware.
Okay, I asked that. Is it that you have a question? You have a video you want to share with us? Someone messaged me and told me that's like you have something you want to share, like a video, maybe a video of the rocket that is being launched, Orbit. You talk about one AI.
I can share the code also. Okay, this code, no problem.
All right, thank you. Thank you.
Python. Python, no C++. Python.
All right. Thank you, sir.
It's an honor to be here. Okay. Thank you so much.
So, thank you all for joining us today. I think we are done for today. It's nice having you here, sir. So thank you for joining us today. Really appreciate your time. Such wonderful presentation. Such wonderful.
Okay. My email. I put my email in the box. Okay. Ready.
Thank you all for joining us today. I hope in one way or the other we've gained one or two things in today's edition of an International Space Technology Convention. So we continue again tomorrow. Tomorrow we have Dr. Clary Naughton from Future Forum to speak with us. And also we have Dr. S. Keza from Space Kids India to speak with us. We also have Dr. Aishwarya D from Innova World. And also tomorrow we have Aluvala K. Chand from Space Rickshaw to talk to us tomorrow. So I would like us all to be available tomorrow also for the program. So the program starts by 10 a.m. Watts, West Africa time tomorrow. The program starts 10 a.m. Watts, West Africa time tomorrow. So it's such an honor to have you all here. Once again, my name is Ayinde Marvelous Oluwatomi. I'm the founder of MAVEX and also the convener of International Space Technology Convention. Thank you all. It's nice having you here. So till tomorrow. Thank you all.